So part A, they want the formula for gravity. So that's F equals G m1 m2 over r squared. And you have to explain each symbol. So what's F?
Force.
The gravity force, yeah? The gravity force between two masses. M1 is mass of the first planet or whatever, mass of the first object. M2, mass of the second object. What's or?
Radius squared.
What's or? What is or? Now you wouldn't get full marks for that. Yeah, the distance between the centers of the masses. And finally, G. Gravity constant. Or, well, maybe I should give it perhaps its full name. Gravitation constant. And the value of it? Yeah, it's 6.67 times 10 to the minus 11, and the unit would be Newton meter squared per kilogram squared. Newton meter squared per kilogram squared. Unfortunately, that's a lot of writing for only 2 marks, but it should be 2 marks nonetheless for everybody. Okay, so B part 1, try it please, and it should take you 2 to 3 minutes to do. So B part 1. It's recording, good. Okay, next part, B part 1. The planet Mars can be considered to move around the Sun in a circle of radius 2.28 times 10 to the 10 meters. The mass of the Sun.
Plus 11.
Thank you, because I should have added 3. The mass of the Sun is 1.989 times, that's 11 there, 10 to the 30 kilograms. Determine the velocity. Okay, so you have a couple of formulas here, and you have one formula for velocity is omega or. But the problem with this is what? No omega. Well, we have this formula for omega 2 pi over t. But what's the problem with that? Do we know the time? We don't know the t. Yeah, now we have another formula. We can say F equals m omega squared or. Now this actually could work because we can use the formula F equals G m over r squared, and together with F equals ma. If I use the F equals ma first, I get ma equals m omega squared or, and here I get ma equals g m over r squared. Those small m's go, and because that's equal to a and that's equal to a, they're equal to each other. So you get omega squared or equals g m over r squared. Therefore, now we have a formula for omega. Omega equals square root gm over r cubed. And that's great because we know the g, the m, and the r. So the v, which equals omega r, that will now equal r times gm over r cubed. So that will be, well, I'll borrow a calculator.
Thank you.
So, let's see. The radius is 2.28 times 10 to the power of 11 times square root. What's wrong? The radius is 2.28 times 10 to the 11, isn't it?
Kilometers.
Yes. And then inside 6.67 times 10 to the power of minus 11 times the mass, which is 1.989 times 10 to the 30, all over, come on, all over radius cubed, which is 2.28 times 10 to the power of 11. So if I put all those numbers in, I get a large velocity, 2412197,622, very big. I should maybe put this in some different unit, like maybe... You were at it. What's wrong with your calculator, Joshua? 24 times 10 to the... times 10 to the 3?
Yes.
Your calculator's a piece of junk. So this comes out as 24 times 10 to the 3 meters per second. Okay. Right, B part 2 now, please. So part 2 is determine the time for Mars to complete one orbit. Okay, so this is part 2. That's actually quite short because t equals 2 pi over omega, and here's your formula for omega. So it's just going to be 2 pi over omega, so just going to be this. Does someone have that for me already? What is it? 600 days. Great. That's not that difficult.
688. Because
137. No, 8.37.
I mean, if they're asking in days, then they would have any decimal to the number of people. It's more than 687.
Let's read the question very carefully then. Determine the time in Earth days for Mars to complete one orbit of the Sun. I see what you're saying, because if it's a part of a day, then that's into the next day.
Or we can put it...
I don't think the people making this question are thinking about it that deeply. So I feel like in the marking scheme, it probably will be 687. But your point is taken, though. I'll leave it at 687. Okay, so now on to part 3, please. Part 3. This time you're given the moon of Mars. You're given the time is 7 hours and 39.2 minutes. I probably need this in seconds, so this will be 7 times 3,600 plus 39.2 times 60 seconds. Okay, the radius of the orbit is 940,000 meters. What's the mass? So in fact, this is an example of Kepler's rule, which is not in the formula book. So you're going to have to prove it or remember it. So you know that F equals GMM over R squared. You also know that F equals M omega squared R. You also know that F equals MA. And you also know that, what's that? Oh, I'm just writing down what we know. T is 2 pi over omega. So I think we can just put these together and we get GMM over R squared equals M omega squared R. Those M's cancel. But omega is 2 pi over T. So we get GM over R squared equals 2 pi over T squared R. So you get GM over R squared equals 4 pi squared over T squared R. Now what are we looking for? The mass. So we have M equals 4 pi squared R cubed over GM T squared. Sorry, what am I bringing the M down for? G T squared. Which is great because we know this, we know this, we know this, and we know this. So if we put in all the numbers, well, someone give me a non-Joshua calculator, please. Yes. No, Casio. Why don't you have Casio 991 yet? Thank you. So 4 pi squared. 4 pi squared times R cubed, and the radius is 9400000 power 3 all over G, 6.67 times 10 to the minus 11 times the time squared in seconds, and the time is 7 times 3600 plus 39.2 times 60. So I got a 10 to 23 is in the math. No? Yeah. 4 pi squared. How many zeros are in my radius? Tell me. Maybe I have too many. How many zeros are in my radius?
5. Originally,
how many do I have now?
Now it's 5.
5. 1, 2, 3, 4, 5. Okay. And the G is 6.67 times 10 to the minus 11. Yes. And the time is. Okay, so it is 10 to the 23 then. Sorry. So the mass is 6.48 times 10 to the 23 kilograms. Did you get that too? Right, great. So part 4, the field strength. So try that next. So now you have gravitational field strength is GM over R squared, which is 6.67 times 10 to the minus 11. What was my mass previously? Thank you. And then the radius is
4.8.
Thank you. Okay, 4.8. Thanks. And the radius is 3396000 squared. So what do we get here? 3.75. Okay. And the unit, do you remember? Newtons? I think it's newtons per kilogram. Yeah. Okay. See part 1 and 2, you can do it now. And you can do both parts together. In fact, for part C, it's a mechanics question, not a fields question. So try part C now. So, see part 1. The probe is dropped from a height of 100 meters and they want the speed when it hits the surface. So I can use v squared equals u squared plus 2af. The u is 0, so I get v equals square root 2af. So v equals square root 2 multiply 3.75 multiply 100. So what's that, please? 27.38 meters per second. Now part 2, we then say that this mass hits the surface and it penetrates a distance of 0.265 meters and its mass is 5.32. Determine the average force, retarding force acting on the probe. So what's happening in this picture here, when the probe hits the ground, there's a force acting up, slowing it down. But let's not forget there's a force pulling it down as well, its weight. So what's going to happen is this blue force will be bigger than the green force because it's going to slow it down to rest. So we could just use, oh by the way, what's its velocity here? 0 meters per second, and the velocity here 27.38 meters per second, so, and this is kilograms. Okay. So I think I'll go with the force will equal the weight, this is the weight, minus this here is the drag. That's what they're looking for, weight minus drag. The weight is mg, and the m is 5.32, and the g is 3.75 minus the drag. So then you get F is MA. Can someone just tell me what that 5.32 multiplied 3.75 is? What is it? Thank you. Minus drag, and the M is 5.32A. So in fact you can get the drag, our answer is 19.95 minus 5.32A. So we just need to get the A. Now be careful, that A is the A when it hits the ground, not the gravity A. So I think the easiest way to get the A would be using the formula v squared equals u squared plus 2af. Now in this picture here, it looks like I was calling down positive. So the v is 0, the u is 27.38 squared, the a I don't know, the s I do know. What's 2 times this? It's 0. Can you just type it in? Just type it in.
0.53.
53.
You have to multiply 0.265 by 2.
Yeah.
Okay.
A. Okay, so I have the A now. The A is minus 27.38 squared over 0.53. So what's that for A, please? Minus
1446.
Okay, meters per second squared. So I get 19.95 minus 5.32, and the A here is negative because it's slowing down into the ground. Minus, is it 14?
1414 points.
What would you got to?
Yeah, 1,400.
1414. Okay, so finally what's the answer here then? It should be quite large. Seven, five, four, two. Okay. So it's 7,540 newtons then, if you do 3 significant figures.
Can we leave it?
Oh yeah, of course, we can leave it here as well. Okay. Right, next please start on number 3, next page.